Dr. Vijayananda Patnaik. Dr. Vijayananda Patnaik is working as Associate Professor and HOD in Electronics and Communication Engineering Department at NIT Raipur. Prior to that, he worked as an Assistant Professor at Department of Electronics and Telecommunication Engineering at IIIT Bhubaneswar for 11 years. Dr. Patnaik obtained his PhD degree from the IIT Bhubaneswar in 2013. He has teaching and research experience of around 19 years. Dr. Patnaik is author and co-author of 70 plus research papers in reputed international journals and conferences, including IEEE, IET, Elsevier, Springer, Liquid, etc. published. In addition, he holds six published patents, out of which 2 have been granted. He is also a reviewer in IEEE, Elsevier journals, Springer, Liquid, and many other international journals and conference papers. He has successfully guided 4 PhD scholars and 19 FA thesis fielded. Presently, 5 PhD scholars are working under his guidance. He has also reviewed as an external examiner for PhD theses of various NITs, institutes, and universities. Also, he is a member of various research and administrative committee of Government of India and Government of Odisha and Government of Chhattisgarh. His teaching and research interest includes communication engineering, system design, quantum technology, advanced wireless communication, optical communication, satellite and radar communication, nonlinear optics, ISOWC system design, etc. So, on behalf of the organizing committee of SOLVE 2026, I warmly welcome Dr. Vijayananda Patnaik and invite him to address this gathering. Sir, please take it.
Thank you. So, good afternoon to all of you. I think am I audible? Yeah, na? Okay. Seda कौन है?
Ida YouTube live.
अच्छा, okay. Hello. 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 There. Hello. Hello. Okay. Thank you. Thank you, all of you. No doubt, after lunch, all branches of students. No doubt, all branches of students. No doubt, maybe mechanical, civil, electrical, computer science, electronics, and all. No doubt, later on, I may be narrow down to communication perspective. But what we can tell in broader sense, communication plays a major role in the present scenario. And the very good example is, so nowadays when you are using WhatsApp or telephoning to your parents or maybe those who are staying outside students, in a day maybe 3 to 4 times minimum you need to communicate. You need to communicate with your relatives, with your parents, with your friends, as well as no doubt WhatsApp messages to each and every minutes we are going to, and as well as news, and all these things we need that it should be updated. So what I mean to say, by looking to this scenario, we can simply say that communication plays a major role. Without communication or without getting information from maybe nearby place or from a long distance, the life will be very tedious. That is what the primary requirement as well as challenge. So in what is then 6G and why it is wireless technology? That is what I want to tell. That different generations of communication has been evolved since 1979. In 1979 it was 1G. Then it comes to 2G, 3G, 4G, 5G, 6G. And you can tell in simple sense what is the generations. As far as our communication is concerned or electronics is concerned, we are telling different generation means data rate. In simple, there are so many other parameters are also there. One of the important parameters is data rate. Data rate in the sense how faster we could able to download a data. If you have to download a movie from a YouTube, maybe 1G, 2G or 3GB data. If it is 1G, it may take 3-4 days. Okay. If it is 2G, within 1 day you can download. If it is 3G, within half day, or you can tell 12 hours you can download. So in 4G, what is good able to download? I will show you an example also. So within maybe 1-2 hours we can download. But in what it is expecting in 6G, within seconds, it is not second, milliseconds, we should able to download the data. It is not only downloading the data or data transfer from one place to another place, machine to machine communication, human to machine communication. Nowadays robots IoTs, drone-based delivery, and communication in high-speed train. This train of the speed is around 600 kilometer per hour. What we are expecting during all those scenarios, how we could able to get our requirement. Requirement in the sense high-speed communication. High-speed communication. If you can able to get all these things, then we can tell we could able to get 6G technology. No doubt with that, so many privacy issue and cost, so many other issues are also there. But today, what I want to highlight is about the speed, how the technology has been evolved, so that we could able to get some previously in 1G, the data rate was around only 10 kbps. From 10 kbps, what you are getting the download, the data is around 1 gbps. Means you can easily imagine 1 GB, 1 into 10 to the 9, 1 into 10 to the 9. Previously, it was 10 kbps, means 10 into 10 to the 3. So 10 into 10 to the 3 or 10 to the 4 is improved to 10 to the power 9 in the present scenario. Clear? And what is expected in 6G is it is not 10 to the 9 rather than 10 to the 12. 1 Tbps speed we are expecting. Clear? Then only what we require. The presently the challenge like high speed train, drone based delivery, IoT devices, all these services we could able to get it. Okay. So that is what the technology we will discuss, and what we are highlighting is mostly all are wireless technology. Why wireless technology advantage that the people can move here and there and they can get the facility. They can get the facility. Like if I would give an example, you will prefer landline telephone or mobile phone. A very good example is mobile phone. Everybody prefers mobile phone. Means wireless technology is becoming more what required or highly required comparing to wire technology. No doubt wire is also used some of the other place, but how to get those higher data rates in wireless technology and how it is involved and what are the challenges in 6G and why you are not getting 1 Tbps of data rate or 1 Tbps of speed, that I want to highlight today. Okay, thank you. Next. So the outline of my presentation will be like this, like introduction, what is 6G, and in 6G, one of the important is optical communication, where our group of students, as well, we are working since last maybe 15 years. And why you are preferring that optical communication that I will highlight, fiber and free. There are various types of optical communication. It may be fiber based or it may be free space optics, and what are the challenges, mitigation techniques, some of the what examples, what I showed you, four-way mixing effect, and some result simulations what we got in our laboratory that I want to highlight. Next, please. Next slide, please. So you see, because it is a combination of so many branches of students, what I thought, I will go from the beginning, from the basics, so that somehow it will be you can get the advantage. So you see, communication. What is communication? Means transfer of information from one place to another place. Where the information is available is basically called a source, and where we have to transfer is called destination. And in between source to destination, we do have what's called communication channel. Am I right or not? I think it is well known to all electronic students. And what is the communication channel distance? It may be 1 meter. What we are discussing, maybe 10 meter or 20 meter. This is also communication. It may be transferred to a long distance. YouTube live streaming is also going on. Means whoever is there from the long distance, maybe 100 kilometer, 200 kilometer, or maybe millions of kilometers, they could also able to watch. Am I right or not? So that is what is the communication channel means from source to destination. The distance maybe varies from meters to kilometers or billions and millions of kilometers. Clear? And as far as the communication channel is concerned, what I told you is wireless. We will highlight. There are four types of communication systems. One is called wireless, and the very good example is our landline telephone as well as cable television. Wireless, which is nothing but our wire, radio, mobile, television, radar. All of you know about it. This is an example. And waveguide and cable communication, which is the example is internet connection, satellite, mobile, and all, where basically the fiber optics also comes to the picture. And why fiber optics is becoming important? Because the ideal bandwidth of fiber optics is said to be infinity. Said to be infinity means whatever the data rate you are expecting, maybe 1 Tbps, 2 Tbps, or hundreds of Tbps can only be possible with only fiber optics. So that is why fiber optics is becoming more important and highly used and technology. And all over the globe, if you will see the communication, what it is going on, more than 95% of the communication channel is only fiber optics. You can tell we are not, it is not visible. It looks like all are wireless, but it is not the thing. In basic, that is why the last one I have categorized, that is called hybrid communication. Hybrid means wireless plus wire or wireless plus fiber optics and like this. So you see, when you are telephoning to your friend by using your mobile phone, so what is happening from your mobile to nearby base station, it is wireless. From that base station, you are talking with a friend who is there in Delhi, for example. From this base station to the base station of Delhi, it is completely optical fiber. Optical fiber. Only from that base station to the user to whom you are going to talk, again it is wireless. If you will see the entire scenario, maximum 5 kilometer and another 5 kilometer. 10 kilometer is wireless, rest all 1000 kilometer. Maybe for example, 1000 kilometer is fiber optics. So by looking to this example, you can tell how fiber optics plays a major role in communication channel, by using which we can tell more than 90% of the channel are fiber optics. So that is why if you want to get a very good or high speed connection, then definitely the fiber or optical, or it is not only optical fiber, it may be optical wireless also. Laser based communication should be well developed. Then only you can able to get the required 6G technology. Next please. So this is what the history you can see, and that 1G already I told you 1975. You can see the data rate was 2 kbps, and how much time to download a 3G. This is an example is given that for 3GB movie. So in 1979 it requires 6 days. Later on 2G 1991 it was developed like 100 kbps, which took 2.5 hours. Means how much it is being well developed. 3G it is 2 minutes. 4G it is around 20 seconds, and 5G within 300 milliseconds we could able to download. It is not that only 3GB, it may be tomorrow 3 TB data also. And what it is, the 6G, how much it is requiring is around 3 milliseconds. So that is what in simple, in brief, what is the difference between 1G, 2G, or what is the development from 1G to 6G. I think it is clear. So anybody any doubt, you can interrupt me at any time. I will be happy to answer. And this is also an example. You see how long time it takes to download 21 TB of file. For example, it is previously it was given only 3GB, but if it is 21 terabytes, then how much? If at all it is 5G, it requires 5 hours of data. You can see that tomorrow, nowadays big data and AI, all these things going on to be evolved like anything. That is why you are getting a huge data. If a huge data, video files, and all these things, it is to be downloaded, then the file size will be very high. So if at all in terms of TB, but still within 1880 second, 18 second, you can able to 6G. In 6G, within 18 second, you can able to download 21 TB of file. Clear? Next please. So this is what an example of why we are expecting or why we require 6G. The example is, we need mobile and internet anytime, anywhere. Because it is not that I will be getting high speed internet only during daytime or maybe only in this campus. It is not our requirement. It is our requirement that at any place, anywhere, I should able to any time, I should get a high speed connection. Clear? The very good example is, it may be inside the building, outside, outdoor the building, when we are walking, driving, as well as subway and high speed train. Nowadays high speed train like Vande Bharat, bullet train is also coming, hydrogen train is also coming. So means where it is expected that the speed of the train is around 300 kilometer per hour. 300 kilometer per hour. What is the speed of this the train? If the speed is 600, whether you could able to get your telephone call, you can go for your internet, or whether you can able to get it or not, that is what challenge. And if it is that is possible, if the data rate will be increased to sufficiently high in terms of what? TBPS. In terms of TBPS. Next please. So this is what user demands. An example like we all require nowadays, all the devices surrounding to us should be connected with the internet. Am I right? Nowadays, in your home, washing machine is there or AC is there, everything is automated and it should be connected with internet. That is why we need in a heavy traffic, also we should be high data rate. As well as autonomous driving, without driver, even source and destination will be fixed, the car should able to go. And for getting that one, you can imagine that what should be the internet speed, what should be the reliability, and how much faster it should be. How much faster it should be. If it is not, if at all it is faster, but still if it is not reliable in the sense, if it is disconnected in between the internet connection, or the mobile connection or the communication, then our what goal will be, or goal cannot be achieved. So that is what the requirement. Similarly, remote healthcare, if there is we have a very good doctor maybe in maybe foreign countries like USA or somewhere, in India we need that facility, then also we should have very high internet or maybe high speed communication facility. Next, already I told you, drone based delivery. Maybe during COVID it was very very important that a human being don't like to move from one place to another place, but the entire things communication should be carried out with the help of drones, and drones should be moved from source to destination. Means you can easily imagine what should be the speed of the data required, as well as reliability, next. So this is what the expectation in 6G, like AR, VR technology. People might have quantum communication. Already I think last time when I came here, I highlighted about quantum and blockchain, mobile edge computing, unmanned aerial vehicles, and cell-free communication, massive MIMO, IRS, intelligent reflecting surface, optical wireless stereo. These are all, if at all we could able to get the facility, then only we can tell our 6G is achieved. You can easily imagine there are a lot of challenges in each and every field. It is remained, so that if at all it is well developed, then we can tell we can get 6G. And in simple sense, you can tell we can get all these facilities if at all the data rate or the communication speed should be very high. Next, please. So you see, this is the user demands that much faster. Already I told you, 10 minimum of 10 Gbps speed. You know what is this data rate or speed we are getting now in case of our what you are telling that 5G. 5G also not well developed, we are not getting. But what is the speed we are getting in 5G? Can anybody tell? In wireless company, you are getting internet connection at your home, maybe Wi-Fi and all. What is the speed you are getting? Any values? 20 Mbps. Maximum 100 or 200 Mbps you are getting. No doubt in foreign country they got up to 800 Mbps also. 800 Mbps. And it is proved that in 5G can provide maximum of 1 Gbps. Maximum of 1 Gbps. That is why in 6G what is expected is minimum of 10 Gbps, 10 times faster, 10 times faster of 5G. Then super connected, thousands of traffic, already I told IoT devices, and higher mobility like 300 km per hour. If a vehicle is moving, we should also get the facility, and ultra reliable, which is very very important. Already I told you. If at all we will get the connection, but if it is not reliable, the reliability is how much? 99. You cannot tell that any system is 100% ideal. So the reliability requirement is 99.999%. Then only it is acceptable for us. Clear? If at all we will get high speed, maybe like autonomous driving, drone bus delivery, remote healthcare, all these things, what we cannot get proper, or we cannot take the proper advantage if the reliability is not there. Clear? In your mobile also, if you are talking in between multiple times, it is disconnected, we will not be happy. Clear? Next is energy efficient. You know, nowadays all are talking about green technology, where energy plays a major. No doubt all these things are internet devices, IoT connected and all. But if at all it requires more energy, we will not be happy. Clear? When you are mobile, you are using mobile also. If you want to charge your mobile 3 to 4 times per day, you will not be happy. Once it is charged with all apps, it should be working for minimum 24 hours. Minimum 24 hours. So that is why the technology, what it is developed, it should be energy efficient. It should be use a renewable energy source. Clear? So these are all what you can tell the expectation in 6G. And as far as the communication perspective, now we'll go a bit in depth about communication. So the 6G, what we require is high bandwidth. You know, all of you know the bandwidth of the system. If you are getting a high speed data, means the bandwidth is very high. If the carrier frequency, I think in communication, all of you know, if the carrier frequency is high, then the system is said to be can provide higher bandwidth, means higher data rate. Am I right or not? And in laser or fiber optics, you are using lasers. Laser communication, terahertz technology, where the carrier frequency is in terms of what? Terahertz, 193.1 terahertz is ideally used for our optical communication. Because the carrier frequency is in terahertz, we can tell that can provide very high bandwidth or high speed. Okay. Next, again, is also it should provide low bit error rate. What is bit error rate? About the noise, about the error. If at all I will transmit 1 Tbps of data, if data is corrupted in the channel, because the channel length already I told you, it may varies from 10 meters to 10,000 kilometers, or it may be 10 billion kilometers. Am I right or not? So that is why for such a higher long distance, we have to communicate, and if the data is being corrupted with error, we will not be happy. We will not be happy. That is a low BER is also our requirement. Next is high SNR, signal to noise ratio. All of you know about the requirement of SNR. If once the noise is less, definitely the SNR will be high. And it should be power efficient, already I told you. And provide data security, because our requirement is also the communication should be well secured. It should be of low cost, but otherwise you cannot afford. And easy to install and maintain. It should also require very low technical skill for operation and all. And 100% coverage, already I told you, no doubt it is not that we are getting high speed connection only in this campus. Wherever you are moving on the road also you should able to get it. In the train also you should able to get it. As well as last one is, yeah, make decisions. Nowadays, I think all of you are familiar with intelligent systems. Neural network, AI becoming more popular. So that the system should have its own what decision power, which is our highly required. That is why the systems are called smart system, intelligent systems. Clear? So these are all requirements in, you can tell, for a high speed communication system. Next, please. And why optical communication? Already I told you, power and bandwidth. No doubt so many parameters I have shown, but out of all, power and bandwidth plays two important resource for any good communication system like 6G. But even a power, how much power it consumes? Already I told you. So you see, in optical, we are using all laser. We are using all laser and LED. I think the optical sources, I think you people might have studied. And laser and LED basically works in milliwatt, very low power, very low power. But if you will go for this RF, like our MIMO or what RF technology, basically the power requirement is in terms of kilowatt. You might have seen the low power transmitters of radio, television, base stations. What is the power it is radiating? It is very much harmful to the human body, as well as it requires more power. Comparing to that, if you come to optical, which is working like in laser, require very low power in terms of milliwatt. Laser power of 10 dBm is good enough to transport the data to millions of kilometers. That is why the optical is becoming more popular, because it requires very low power, very low power. Then again, bandwidth, already I told you, the typical ideal bandwidth of the fiber is infinity. Fiber is infinite. That is why what we need, the higher data rate or high bandwidth applications can be possible with the help of fiber optics. So that is why terahertz systems or optical systems require very less power, which is in terms of milliwatt or dBm, and have a very huge bandwidth, which is in terms of hundreds of terahertz. That is why these are all widely accepted, and that is why government and all are spending millions of dollars for making these lightweight systems to be and more what reliable, or more it should be it should work widely, and okay, so that is why what I mean to say, in 6G, optical plays a major role because of its low power consumption as well as providing very high bandwidth. And people used to tell that optical means always it is optical fiber, but so that is why it is even classified. It is not only optical fiber, rather than it may be fiber, it may be wireless optical, it may be hybrid. What is hybrid? So hybrid means combination of fiber optics plus wireless. Already I told you, in real time, whatever the systems you are getting, each and every system has its advantage and disadvantage. Fiber optics has the advantage that we can cover long distance, but the disadvantage is it is point to point, point to multi-point. Broadcasting cannot be possible. So that is why we have to go for wireless. We have to go for wireless. Or when we require mobility, you have to, the user can move here and there, and he want to get the facility, then wireless is highly required. So that is why, by looking to this advantage and disadvantage, hybrid systems are more popular. Clear? So that is why fiber optics means through laser and through a single fiber, we are transmitting the data. You know, total internal reflection is the basic principle of fiber optics, by using which we are transmitting. Next is wireless. What is wireless optical? We can put a laser here, and we will take the receiver at that other corner of the wall from one place to another place. If there is no fiber, through a pointed laser, if the communication is carried out, then it is called our wireless optical communication. Wireless, that is also laser, but there is no fiber. Only what? Transmitter to receiver, it is through free space, the communication is carried out. Then only it is said to be wireless. And why? What is the advantage of wireless? Already I told you, the advantage of wireless is mobility. The person can move here and there, and they can get the facility. Or one point to multi-point communication can be possible, like mobile phone instead of landline telephone. And that is what wireless and hybrid. And fiber optics is also various types like WDM, DWDM as the technology evolved for utilizing the huge bandwidth. What wavelength division multiplexing, dense wavelength division multiplexing systems has been developed. Then wireless is also two types like line of sight and non-line of sight systems. Line of sight, whenever transmitter to receiver, point-to-point communication is going on. And what is a DL? Diffuse link means point to multi-point. What do I require the broadcasting is from one point to multi-point. One point to multi-point. That is why that is also there are two types. And hybrid already I told you it is the what taking the advantage of disadvantage of what systems we are basically combining, and that is what called our hybrid communication system. Next please. And optical communication type, that is why I have written fiber optics communication, free space, optical. What is free space and what is the optical wireless? Both look similar, but basically, whenever it is a terrestrial communication, people use to tell FSO or free space optics. And whenever you are going for deep space communication from one point to another point in the space, like satellite and all, then that is called your optical wireless. And inter-satellite, from one satellite to another satellite, if the communication is what optical, like your laser based, then it is called our ISOWC. Then underwater communication, underwater communication is also required, as well as hybrid optical. These are all different types of optical systems. And because all uses laser, which is a high carrier frequency, which can provide high bandwidth with low power, it is becoming more popular in 6G technology. Next please. This is an example of fiber optic systems. Source to destination. If a dedicated cable is placed and that is a fiber, then it is called our fiber optics communication. And what is the difference of fiber communication and wire communication? Wire communication, the communication is carried out through the core of the wire. Core of the means the current will be passing through the conductors. But the basic operation of fiber optics is total internal reflection. The light will be reflected from the walls of the fiber and or through the core of the fiber. Through total internal reflection, the communication will be established. Got it? Next please. Then this is an example of free space from one building to another building. We are using a laser. What I told you, there is no fiber, and the communication is achieved from transmitter to receiver. And the main demerit of optical wireless is it cannot be long distance, like millions, billions, even if thousands of kilometers also we cannot expect in FSO, free space optics. Only we can get some maximum of 900 meter or 1 kilometer is achieved. 1 kilometer is achieved in wireless optical cable. Clear? That is why hybrid is becoming more popular. So that combination of both these things can be used in different scenarios. Next please. This is an example of FSO where we have the transmitter and receiver, and there are two lights. One is green, another is, you can tell, pink. Why there are two lights here? Can anybody tell? It is showing that the free space optics is being transmitted with the two colors of light. One is green, another is, it may be different in any color. It is not that pink and green. It may be blue, black, maybe any other color. Why there are two? Because it is a full duplex communication. Basically, what we require is all our full duplex. When you are talking with your friend, you should be able to listen, as well as you should be able to tell both these things parallelly. Clear? So that is why the laser communication in FSO is a full duplex. Transmission and reception will be carried out simultaneously. Next, please. So this is also one more scenario where by using laser from one building to another building in a metropolitan city, the high-speed communication is being established by using laser technology. You can see here fiber optics is the backbone which is providing 2.5 to 10 Gbps of data. But whenever it comes to our wireless or like our Wi-Fi, we are getting hardly 200 Mbps. 200, but you told that 30 Mbps, 200 Mbps you are getting. We can see here that 10 Gbps is reduced to, or 2.5 Gbps is reduced to 20 Mbps or 30 Mbps, which is very much challenging. So that is why optical wireless people are working hard. How? That no doubt this 10 Gbps we are getting throughout the globe by using the fiber, the same 10 Gbps is also should be reached to the user end. Clear? That is what the problem is also called a last mile and fast mile problem. Last mile means where we are using the optical or where we are using the wireless. If that wireless is optical wireless, then we can able to get data rate of Gbps. Otherwise, it is only Mbps because all Wi-Fi technology are working in RF, not in optical. Got it? Next, please. Then we can see because of fiber optics and all plays a major role. What are the challenges? If you know certain challenges, I will highlight. Then only you can able to tell, or you can able to think that what you can able to solve or what contribution you can give to the technology. There are so many challenges found in fiber optic system. No doubt it has been laid throughout the globe. One of these is fiber non-linearity and dispersion, because any medium you are taking, and these are all completely non-linear in nature. I think all of you know what is non-linear. When I will transmit the output data y equal to a plus what xb, y equal to a plus or x square plus y square, y equal to x square plus 2ab, whatever it may be. If the equations are like this, then these are all called non-linear. And this non-linearity means if I will transmit x, instead of y I am getting x plus x square plus 2x, x square plus 3x, and all these. And why? Because this is what? Because of the property of the medium, like fiber. And another is dispersion. What is dispersion? Can anybody study dispersion? Dispersion means pulse broadening. If I will transmit a narrow pulse, at the transmitter, after traveling a distance of around 100 kilometers, the narrow pulse is becoming broadening. That is what called our dispersion. And then what is the problem? If it is a broaden, we should not bother. But why you are bothering? Because if I will transmit the data 101, for example, 101 means one pulse I will transmit, another pulse is off. Again I will transmit one pulse, and if the pulses are broadened, then 101 may looks like 111 at the receiver. That will create error. That is called BER, bit error rate. So that is a dispersion plays also a major role, and how to eliminate the dispersion. If at all you are unable to eliminate the dispersion, then what will happen? The data will be corrupted. Data will be lost. Information will be lost. Clear? That also plays a major role. Then all optical communication, already I told you. And in what is happening? We are getting 2.5 or 10 Gbps of data in fiber. But as you are coming to the user and like in our Ethernet cable or through Wi-Fi, we are getting hardly 200 Mbps, 300 Mbps or 1 Gbps of data. Clear? So that is why it should be fiber optics plus optical wireless. Then we can tell that is all optical technology. All optical technology. From source to destination, entirely it is optical. Maybe fiber plus optical wireless. Then we can get the high speed data. Okay. Next is intelligent fiber optics. Already I told you the devices should be intelligent enough so that if at all there is some problem in the device, it should respond its own. I think in mobile also you might have listened earlier. There was a technology called MAHO, mobile assisted handoff. What is mobile assisted handoff? Whenever the mobile network is low, base station need to be changed. Who is going to change it? So that is a mobile should have its own intelligence. The mobile should inform to the MSC that my network is going to be poor. You please change the base station. Then only it will be changed. Are you good? Those are all called our intelligent systems. Then optical neural network, because if you want to get an intelligent system, when neural network plays a major role, I think all of you know. And no doubt what is the neural network you are studying, all are working in how much? Maximum of 10 megahertz. 10 megahertz. But what I am talking here is in terms of terahertz. Terahertz, that is also the major challenge. Then improvement of optical amplification technology, because you saw any electronic device we are using, all are frequency sensitive. All of you know, all are frequency, means we are not getting till now a wideband amplifier or an amplifier which will pass all the signals. All pass amplifier is not possible. Clear? No doubt I am telling the fiber bandwidth is infinity, but if I will transmit infinite of data, there is no amplifier which has the bandwidth is infinity. Each and every amplifier has its own bandwidth. Am I right? What we are designing, the filter, amplifier, modulator, demodulator, oscillator, each and every electronics device has its own bandwidth. It will work for a particular band of frequency. Like antenna also, when you are using the antenna, basically use it at what frequency it will work, whether it is USS or ultra high frequency or super high frequency or maybe RF. So that is why bandwidth plays a major role, and that is why developing of the optical amplification technology at for a very wider band is a very challenging issue. Clear? Maximum bandwidth like EDFA, erbium dipole fiber amplifier, provides a bandwidth of hardly 50 nanometer. 50 nanometer. More than that, it is not well developed. Are you good? That is what the challenge. Next is long haul fiber optics communication. What is long haul? Already I told you the fiber optics technology is established throughout the globe. millions and billions of kilometers fiber are laid throughout the globe. Am I right or not? Then how to achieve? No doubt fiber optics is available, but multiple times we are using the repeaters. I think you in fiber optic you might have seen there is a device that is called repeater. Repeater. Clear? What is the duty of repeater? After a certain distance, because of the fiber non-linearity, fiber dispersion, all these things should be minimized and it should be again retransmitted. What is the duty of a repeater? Repeater means it will receive the signal, removes the noise, non-linearity, dispersion, again retransmits. Again, without changing the information. Without changing the information. So that is why for long distance, maybe millions and billions of kilometers, what are the repeaters we are using? The number of repeaters are in terms of thousands and billions. So that is why how to reduce the number of repeaters for a long distance communication, fiber optics communication, that is also another challenge. Another challenge. If at all it is reduced, then only it is cost effective. Am I right or not? If somebody will use 1000, maybe 1000 repeater, another will use only 500 repeater. Definitely 500, if somebody can develop the technology with 500 repeaters or 50% of reduce, then it is well accepted. That is what also one of the challenge. Then advanced modulation format, multi-dimensional nowadays so many advanced modulations come to the picture, and modulation plays a major role because of what advanced modulation, what is happening? Fiber non-linearity, dispersion, attenuation will be reduced. So that is what also highly required. Then equalization techniques. I think equalization all of you know. To eliminate the channel distortion, what you are using the inverse filters. Inverse filters. Clear? That is also to be well developed. Then you can tell the channel effect can be nullified. Next is coding. I think all of you know coding. Like in communication, if you will see, there are three types of coding: line coding, source coding, and channel coding. Clear? So all these technologies should be well developed. Then only we can achieve what? With low error, high speed communication system. Clear? And what is the use of channel coding? Minimization of error. Requirement of source coding, compression of data compression. You might have Hoffman coding, DC compression techniques. Those are all what you can tell. Means instead of 1G file, if at all it is compressed with 500 Mbps, half of it also you can able to transmit. Am I right or not? You know, no doubt the data, it may be lossless technology, maybe lossy technology. There are different types of coding is also there. Clear? What I mean to say, if at all this coding, like line coding, channel coding, source coding will be developed, then only we can get this high speed connection. Then similarly, it is not only the fiber, rather than free space optics is also the challenge. One of the major challenge in free space optics is absorption and scattering. Clear? Already I told you the free space optics will be used maximum of distance of 1 kilometer. Beyond that it will not work. Why? Because of the absorption, atmospheric absorption. Clear? We are transmitting the laser light, it is being absorbed. If it is being absorbed means the power is lost. If the power is drastically reduced, then we cannot go for long distance. Clear? That is why instead of 1 kilometer, how to develop to 1.5 kilometer, 2 kilometer using what? Optical wireless is also an highly required. Similarly, atmospheric turbulence plays also a major. What is turbulence? You know, the change in refractive index of the atmosphere because of temperature and pressure variation is basically called turbulence. Clear? And why? Because we are transmitting through the free space, the laser communication. What is happening? If the medium refractive index will change, the behavior of the laser light will change. So that is why keeping that refractive index to be a fixed one is a challenging thing. Like if at all we could able to get a very good communication maybe in summer. But during winter, what is happening? The atmospheric temperature and pressure will change. What I mean is the atmospheric temperature and pressure varies with respect to climate. Maybe during daytime, mid of the day, during night, all these things, the temperature and pressure of the atmosphere is different. Am I right or not? If the temperature and pressure is different, refractive index will differ. If the refractive index will differ, the laser communication will be distorted. So that is what the challenge. How to get a high-speed laser communication, free space wireless optical communication with different climatic conditions throughout the day, throughout the year, and throughout different seasons. That is what also the challenge. Next is beam divergence. You know, whenever we are transmitting beam, it is pointed, it may not be well pointed properly. The beam may be diverged. Similarly, pointing error exactly to the receiver, it should be pointed out. But if it is not pointed, you have to take care. Then ambient light. You means when I will transmit a light maybe from here to there, red light. then what is happening? This white light contains all the frequencies. Am I right? You know, all of you know, white light. What is the frequency of white light? It is the combination of all other lights. Clear? That is why if I will transmit a laser light of red color, this white light also some parameter, some portion of it red light is also there. That is why the background light may also